Buffers for proximity analysis. A buffer is a polygon surrounding map features of a feature class. As an analyst, you would specify a buffer's radius. Then the buffer tool will sweep the radius around each feature, remaining perpendicular to features to create buffers. For points, buffers are going to be circles. For lines, they're going to be rectangles with rounded endpoints. And for polygons, they're enlarged polygons with rounded vertices. Generally, you use buffers to find what's near or proximate to the features being buffered. Often, buffers are used to delineate zones around the features or to show areas of influence. So for instance, maybe you have a school and you want to create a zone of illicit drug dealing around that school. That would be perhaps a polygon or a point feature for the schools, and then the zones around that. Sometimes you use buffers to clip features. Maybe you're creating a buffer around a water feature and you need to then clip other features around that. Or buffers can be used to select features in another feature class. These are just a few of the examples of the many uses for proximity buffers. Let's take a look at some more detailed examples of points, lines, and polygon buffers. Let's start by looking at point buffers. In this first example, let's say that you want to do an environmental justice study looking at polluting companies and whether or not the persons living within a proximity of those polluting companies have a higher or lower status of poverty. In this case, we're back to Hennepin County, Minnesota, where Minneapolis, St. Paul are. And what we're looking at on the map are polluting companies as red circles. We could obtain such information from places like the Environmental Protection Agency or EPA. From there, we can create our proximity buffers, which are shown by the yellow circles. Those are 2-mile buffers around each of the polluting companies. And you'll see that in some cases you can dissolve the buffers so the two buffers would run into each other. Then what we could do is take something like point centroids for the census data. And those point centroids might have information about the poverty. So we could create those point centroids, get the poverty information from the Census Bureau, and use those proximity buffers along with the point buffers, or the point features for the point centroids, to determine things like proximity. So if we do this, we could see that using something like select by location simply would tell us the mean percentage of the total population living in poverty. And in fact, within 2 miles of the top polluting companies, there are about 23% of persons living in poverty. If we look outside of those 2-mile buffers, the mean percentage of poverty is much less. It's only 9.54%. So this may be the start of an investigation for environmental justice around polluting companies. Another example of using point buffers is a project that I recently did for the Director of Physical Fitness for Pittsburgh Elementary Schools. The Director of Physical Fitness was interested in expanding the ability to have students leave a school, get to green space, perhaps use that green space for physical activity, and then get back to school within 5 minutes. So what we did was we created 5-minute walking buffers around every elementary school in the city. In addition to our buffers, they had done a survey. So we have those survey results here too, looking at the sizes of the gymnasium. Do they have a cafeteria where students could play? Does the playground, what is the size of the playground in the fields near the school? Is that cafeteria even available? Do they have empty classrooms? And then also the sidewalks. So in this case, I created these proximity buffers just to show how far you could get within a 5-minute walk from every school. You may also take this project a step further and do some analysis of the amount of green space that might be within a proximity of 5-mile walk to our school. So in order to do that, you might use the buffer and use it as a clipping tool to then calculate the acreage of green space near the schools. This proximity buffer that we're creating around points is what we call as the crow flies buffer. So it doesn't necessarily indicate that there are streets, in fact, that could be used to get to that green space. We'll take a look at that later on when we get to street networks. Another point proximity buffer example deals with physical features. In this case, let's say that we're interested in a safety study for a university campus, and we're interested in lighting. Is the lighting sufficient near things like parking garages or walking paths? In this case, you might use a tool that like Esri's Collector app to collect the information about lighting on campus, create those as point features, and then create your proximity buffers. So the example that we're using here is lighting, but these could also be something like Wi-Fi. What is the Wi-Fi coverage at a university or other area of a city? So you can see that the point proximity buffers can be very useful for a number of different projects, including physical attributes. Line buffers. The first line buffer example that we'll look at is a transportation study. Let's say that you have a bus line, and you want to determine the number of bus stops that are within a walking proximity of that route. Well, you could take the route, which I have highlighted here. This is near Carnegie Mellon's campus, Forbes Avenue, and I've created a proximity buffer around that. So let's say I'm looking at a 5-minute walk around that route. I might want to then know what are the bus stops along that route or within a proximity of that. You might also want to know how many people have an access to each one of those routes or the stop. So you could use either point buffers and create proximity buffers around that to know the amount of people that are within a bus stop, or you might have a line buffer to create that around the route to create a proximity of stops or persons around the entire route. Another example of a line buffer might be an access to work study. This was a project that was conducted by a local foundation a few years ago here in Pittsburgh. They were interested in looking at a low-income neighborhood and using the centroid of that neighborhood just as a starting point to determine how far you could get within a bus route. So in this case, this was looking at a neighborhood called East Liberty, and it was looking at the bus routes that were along that neighborhood from its centroid. So it used the lines for the bus routes as the buffers. Now there was a little bit more that went into the algorithm of determining this, such as the number of stops a bus make and also speed limits along those routes. But this is an example of a line buffer looking at 15-minute drive time from the center of that neighborhood. Then you might add another buffer. So let's say we want to determine how far we could get within a 30-minute bus route. So you can see that this then extends into other parts of the cities beyond that neighborhood and its adjacent neighborhoods. It even gets into some of the suburban areas. If you wanted to take a 45-minute bus route, you can get even further and very far with a 60-minute route. Now, one of the things you would want to do perhaps in a study like this is then overlay this with employment opportunities. Maybe you have different kinds of opportunities of different kinds of businesses. So you could then count how many businesses perhaps would be within each buffer. Or you could also count the populations within these buffers. But the basic idea here is that these lines, being the transportation routes, are used as the buffer. Polygons and multi-ring buffers. In these next examples, we'll take a look at a different use for buffers using multiple rings. Before we look at that, let's review Newton's law of gravity. The attraction between two objects falls off by the inverse of the distance between them. If we look at that analogy in human behavior, we see that it's very similar. What do we mean by that? Well, the further a potential client is from a service, the less likely he or she is to travel to use it. In the next two examples here, these are examples that I've done related to healthcare, and they use multi-ring buffers. The first example is looking at obesity. In this case, I was working with researchers at Children's Hospital of Pittsburgh looking at what we call the BMI Z-score. BMI means body mass index, and the Z-score means the change in the body mass index of patients over a 5-year period. So we were looking at patients that had a significant decrease in their body mass index, meaning they lost weight. Those are the negative numbers shown as blue circles in the maps. And then patients who had a BMI Z-score increase, a significant increase over a 5-year period in their body mass index. So we were looking at that, but also in relationship to green space, to see if green space and parks would have an impact on improving childhood obesity. Another side step to this project was looking at their proximity to fast food, but in this case, the multi-ring buffers were used to look at their proximity. So we had two buffers. We had a 600-foot buffer and a 1,200-foot buffer. The 600-foot buffer looked at the true proximity or close proximity to parks and green spaces. And through our research, we found that this was a pretty good, easy walking distance to a park. So the basic question was, if a patient lived closer to a park, were he or she more or less likely to lose weight? And the initial research showed that, in fact, patients that had a moderate BMI decrease, those that lost weight, about 43% of those lived within a 1,200-foot buffer of a park. If we look at those that increased in their BMI and the 1,200-foot buffer, we see that 83% of these lived further than that 1,200-foot buffer from a park. And we did further research to see the closer proximity of the 600-foot buffer. And in fact, the patients that lived closer to those also had a significant decrease in their body mass index as opposed to those that lived outside of that buffer. But the point here is looking at that distance between the 600-foot and the 1,200-foot buffer and beyond as proximity buffers with multi-rings. Now, of course, this was just one criteria for looking at why a patient may have lost or gained weight. In fact, we had to look at what was the happening in the park when they got to the park. Was it a wooded area? Was it a playground? Was it conducive to play? Other things like safety and the access on streets to the park. So there was a lot that went into the study, but it was a good initial exploration to see whether or not parks might have an effect on childhood obesity.